concerned, there we define batteries and even we consider the types of batteries, that is primary batteries and secondary batteries, and even we studied examples for primary as well as secondary batteries. And we even studied about some important cells, that is fuel cells, that is particularly we specified hydrogen oxygen fuel cell. Advantages of the fuel cells as they have high efficiency, pollution free working, and even they are used as a continuous source of electricity. And regarding the uses of fuel cells are used in the spacecraft or can say space projects. There whatever the byproduct formed during cell reaction, water which is used as a drinking water supply for astronauts. Well, in this session we go on one more concept called corrosion. So basically corrosion is nothing but it is the loss of metal. This corrosion is nothing but it is a loss of metal in the form of compounds. So usually we know that metals are electropositive and being reactive in nature. They readily react with the atmospheric species. Means whenever metals come in contact with the atmospheric gases like oxygen gas or carbon dioxide gas in presence of moisture content, what happens? That metal shows the reactivity. Okay, so we say metals they react with those species present in the environment and get converted into corresponding compounds. Usually we say they may be converted into their oxides, they may be converted back to their hydroxides. Okay, so we say if they get reacted with the chemical species present in the environment and get converted into some other forms rather than metal, then the phenomenon is referred as a corrosion. So basically what we say, the loss of metal in the form of compounds due to chemical attack by the constituents of the environment, okay, is called corrosion. Well-known examples for corrosion are rusting of iron is a well-known example. Usually we know iron will be get converted into its oxides during rusting. So iron will be lost in the form of a rust. So rusting of iron is a well-known example of corrosion. Similarly, you might have seen whenever you think of copper utensils or even silver utensils, what happens? Their surface will be tarnished. They loses the brightness or you can say lustrous after a time. It means that tarnishing of copper surface, tarnishing of silver surface, or tarnishing of some utensils, okay, aluminum utensils, is also example for corrosion. So these are well-known examples for a corrosion. So basically, what is corrosion? It is the loss of metal in the form of compounds due to the chemical attack by the constituents of the environment on a metal is called corrosion. Now coming to the factors affecting corrosion. So there are four major factors which affect the rate of corrosion or I can say extent of corrosion. So the rate of corrosion depends on what is the first factor? Reactivity of metals. We know that metals are not equally reactive. Some metals are highly reactive, some metals are least reactive, and some are moderately reactive. Okay, overall metals are reactive, but the reactivity differs. Now here, extent of corrosion, or I can say rate of corrosion depends on the reactivity of the metals. If the metal is more reactive, in the sense the more electropositive metals get corroded faster than the metals with the low electropositive nature. Means higher the electropositivity, reactivity of such metals will be more, therefore they readily get corroded. They readily undergo corrosion. On the other hand, if the metals have very low electropositive nature, their reactivity will be less, therefore they undergo corrosion slowly. It means the rate of corrosion depends on the reactivity of the metals. So what we are saying here, the more electropositive metals get corroded faster than the metals with the low electropositive nature. So it's the first factor. Second factor, nature of the metal surface. So usually if the surface is plain, completely plain, then what happens? The the rate of corrosion or extent of corrosion is less. On the other hand, if the surface of a metal contains imperfections, we used to call imperfections, it may be in the form of bends or it may be in the form of scratches. At that moment, we used to call peaks, bends or scratches. They are referred as imperfections on a solid surface. If there are imperfections on the metal surface, what happens? Again, such metals readily undergo corrosion, or I can say they corrode at fast. So what we said, if the metal surface contains bends or scratches, so generally I can say imperfections, then what happens? Corrosion takes place rapidly. So here the second factor, nature of the metal surface. Nature of the metal surface in the sense, what we are considering? Imperfections. Larger the imperfections, that metal readily get corrodes. Lesser the imperfections, metal corrodes very slowly. So is the second factor, nature of the metal surface. Then coming to the third one, air and moisture. So these are the major, it's a major factor which is responsible for corrosion of a metal surface. So presence of air and moisture around the metal surface increases the corrosion. Means whatever the air, gases is present, carbon dioxide, oxygen gas. If there is a moisture, that is water content, what happens? The carbon dioxide dissolves in moisture content and get converted into carbonic acid, that is H2CO3. So what happens in the nature? If the more and more carbon dioxide dissolves in moisture content, there will be formation of a carbonic acid. So in turn, that corrosion will be enhanced in presence of a acids. Okay, so we said air and moisture is also the factor which influences the corrosion. So the presence of air and moisture around the metal surface increases the corrosion. So is the third factor. It means if the metal is present in vacuum or in absence of moisture content, what happens? The rate of corrosion will be very less. Okay, right. Then the fourth factor, presence of electrolytes. So in presence of substances like sodium chloride, or generally electrolytes, again what happens? The rate of corrosion increases rapidly. So these are the four factors which influences the extent of corrosion, or I can say rate of corrosion. So what are those? Reactivity of metals. Second, nature of the metal surface. Third, presence of air and moisture. And the fourth one, presence of electrolyte. So it's regarding factors affecting corrosion. Well, coming to the rusting of iron. Rusting of iron is nothing but is a kind of corrosion. Here what happens? Iron is being lost. Iron is lost in the form of its compound. Well, here rusting of iron means when iron is exposed to moist air. Remember, I have to specify here when iron is exposed to moist air. It means if there is a dry air, in a sense if there is no moisture, what happens? There is no rusting of iron. So here things to be remembered is when iron is exposed to moist air for a long time, what happens? A brown color coating of hydrated ferric oxide is formed or developed on its surface. So when iron is exposed to moist air for a long time, a brown coating of hydrated ferric oxide Fe2O3.3H2O okay, develops on the metal surface. This phenomenon is called rusting. By considering the chemical reaction involved, how we can define rusting of iron? When iron is exposed to a moist air for a long time, for a longer period of time, a brown coating of hydrated ferric oxide develops on its surface. That phenomenon is called rusting. Or else, simply what I can say, the corrosion of iron. Rusting of iron is nothing but corrosion. So we say the corrosion of iron surface when it comes in contact with the atmosphere. Okay. So the corrosion of iron surface when it comes in contact with atmosphere is called rusting of iron. So what is the thing to be remembered here? Rusting of iron takes place only when it comes in contact with the moist air but not dry air. Similarly, the rusting of iron takes place only in presence of moist air and but not in vacuum. So necessary condition is if rusting takes place in the sense there will be a moist air and there is no vacuum. If iron is present, if it is in contact with the dry air and if it is present in a vacuum, then there is no rusting takes place. Okay. So it is regarding rusting of an iron. Well, if I consider chemically what happens during rusting of iron, say consider it is the iron surface of an iron. Say whatever the peaks, whatever the crack I have, it is considered as an impure part of an iron. As I already mentioned, surface of a metal, or I can say metal surface, if there are bends or cracks, then I can say imperfection. Say it is a part, it contains imperfection, so it is the impure part. It is considered as an impure part of an iron. Rest of the surface is considered as a pure part of an iron. So during rusting, what happens? This iron surface, which is in contact with the moisture. Say I consider a droplet of moisture, water droplet containing dissolved carbon dioxide and oxygen. When iron surface containing pure part and impure part, when comes in contact with the moisture, it acts as a miniature of electrochemical cell. Means it acts as a simple galvanic cylinder. So what happens? The pure part of an iron, that is the portion which contains bends, that is impure part. Other than that, considered as a pure part. The pure part of an iron, it acts as anode. The impure part of an iron, it acts as cathode. Means there are two electrodes. Part of the iron, that is pure part, acts as anode and impure part acts as a cathode. And the moisture containing the iron surface, when comes in contact with the moist air, that moisture containing dissolved carbon dioxide and oxygen, it acts as a electrolyte. So this droplet, it acts as a electrolyte. Well, we know generally oxidation takes place at anode and reduction takes place at cathode. Now what happens here? Whenever carbon dioxide dissolves in water, what I said, that is in moisture, what happens? There will be formation of a carbonic acid, H2CO3. Is a weak electrolyte, it splits into H plus ion. In the sense, this moisture droplet contains H plus ions. Well, it also contains oxygen content, it has H plus ions. Now, in pure part, what happens? The iron atoms of a pure part undergo oxidation readily. So, iron Fe undergo oxidation. So, iron is get converted to Fe2 plus. The ferrous ion goes to moisture. Fe2 plus ion goes to moisture. While electrons are transferred to impure part. At pure part, what happens? The iron atoms undergo oxidation. The ferrous ion goes to solution, while electrons are being transferred to impure part. So, this process continues. So, Fe2 plus ion continuously goes to the moisture content, while electrons are continuously transferred to impure part. Now, at the surface of a impure part, now what happens? The H plus ions combines with the oxygen content and get converted into water. Here, reduction of oxygen takes place. Oxygen is getting reduced into water molecules. On the other hand, the ferrous ions are further oxidized into ferric ion. In the moisture content, what happens? These ferrous ions are further oxidized into ferric ion, and ferric ions combines with the hydroxide ions of a moisture and get converted into ferric hydroxide. Later, this get converted into a stable form of its oxide, ferric oxide. So ultimately, what happens? There will be conversion of iron into part of the iron is get converted into its oxide, ferric oxide. So we call hydrated ferric oxide. So what happens here? Iron is being lost. Part of the iron is being lost in the form of its compound. Therefore, this phenomenon is considered as a corrosion of iron. Well, what is the phenomenon included here? Electrochemical phenomenon. Therefore, we study rusting of iron is studied. Rusting of iron is studied as a electrochemical phenomenon. So what we are saying? Rusting of iron as a electrochemical phenomenon. So what happens here? Say rusting and other forms of corrosions are actually the electrochemical processes. The electrochemical processes involving oxidation as well as reduction. So in iron what happens? The atoms of iron lose electron to form Fe2+. As I said, the pure part of an iron get converted into, or I can say it is undergo oxidation and liberates electron. What is the electron potential here? Minus 0.44 volt. So iron ions goes to moisture content and electrons are transferred to impure part. Further, whatever the carbon impurity present in the iron behaves like a tiny electrode where reduction takes place. Means at impure surface, what happens? The H plus ions are reduced to water molecule. The H plus ions combines with the dissolved oxygen molecules in presence of electron gives rise to water molecule, and its electrode potential will be 1.27 volt. Further, whatever the ferrous ions present in the moisture content, they undergo oxidation to give ferric ions and hydroxide ions. So, ferrous ions combines with the water molecules and oxygen content get converted into ferric ions and hydroxide ions will be liberated. So these ferric ions readily combines with hydroxide ions gives rise to ferric hydroxide. This ferric hydroxide further converted into ferric oxide, that is hydrated ferric oxide. So it is a reaction involved during rusting of an iron. See, it is one of the important concepts. It is rusting of iron as a electrochemical phenomenon. Well, I hope you understood this. Then, if I consider methods of preventing corrosion of metals. If you leave the metals to get corroded, what happens? It's a great economic loss. Therefore, to avoid this, it is necessary to think of prevention of corrosion. Prevention of corrosion of metals. So there are basically three methods by which it is possible to prevent the, or I can say it is possible to cut the extent of corrosion, prevent the extent of the corrosion. What are those? Barrier protection, second one sacrificial protection, sometimes it is also mentioned as a cathodic protection, and third one by using anti-rust solutions. So these are the three major ways by which we can prevent the corrosion of a metals. Well, first one, coming to the first one, what is barrier protection? Here what we are saying barrier. Basically we know when metals get corroded, when metals comes in contact with its environment, or I can say atmosphere, then only is going to be get corroded. Now between metal surface and the environment, now we are thinking of in between metal surface and environment. If you create a certain barrier, if you place a certain barrier, so that what happens? Metal surface won't comes in contact with its environment, so it is possible to prevent the corrosion. So it's a simple idea behind this barrier protection. So what we are doing in this barrier protection method, a thin barrier is developed. A thin barrier is developed between surface of the iron and atmosphere. So what we are doing here? A thin barrier is developed between surface of an iron, or generally I can say metal, and the atmosphere by the following methods. So how we are creating barrier? It can be done by painting. Means a thin layer of paint if it is placed, what happens? We are going to create a barrier here. So by painting, we can create a barrier. Second, by coating the surface, with a thin film of oil or grease. So it's the second way of creating a barrier. Means if you place a thin layer of either grease on the surface of a metal, then also we created a barrier between metal surface and atmosphere. So this is the second one. Third one, developing a thin layer of non-corrosive metals. Say non-corrosive means they are not undergoing corrosion. So by developing a thin layer of non-corrosive metals like nickel, chromium, copper by electroplating technique. So these are the three ways by which we can create a barrier between metal surface and atmosphere, so that we can prevent the corrosion of a metals. So it is regarding barrier protection method. Okay. Well, second one, what it is? Sacrificial protection. So here sacrifice means losing one for another. We are going to lose cheaper metals to prevent the corrosion of a costlier. So what we are doing here in sacrificial protection, the surface of iron is covered with more electropositive metals. More electropositive metals like zinc or aluminum. Now what happens here? So iron surface is coated, that is electroplating itself. Iron surface is coated with more electropositive metals like zinc or aluminum. Well, in that case, what happens when the iron surface coated with zinc or aluminum, when it comes in contact with the atmosphere, now what happens? There is either zinc layer or aluminum layer present on its surface. That zinc or aluminum layer undergo corrosion. That layer, the zinc layer or aluminum layer comes in contact with the atmosphere. Therefore, that layer is get corroded, but not the iron. So what we have done? We lost zinc layer or aluminum layer to protect the iron surface. Therefore, we call it is a sacrificial protection. So in this metal loses the electron more readily than iron, and rusting is prevented. This type of protection is called sacrificial protection. Means we are losing one metal to protect the corrosion of another metal. So here the process of coating a zinc metal on the surface of iron is basically called galvanization. Okay. So in sacrificial protection, what we are doing? The surface of iron is coated with the more electropositive metals like zinc or aluminum. Well, it's regarding second, sacrificial protection. So this sacrificial protection can also be considered as a cathodic protection, or we can say electrical protection. Well, what we are doing in sacrificial, what we said, this method is used for, especially this cathodic protection, this method is used for underground iron pipes. The iron tank or iron pipe is connected to more electropositive metals. The surface of iron again is coated with the more electropositive metals like magnesium or aluminum. So by doing so, what happens? The more electropositive metal act as anode and iron act as a cathode. Thus, iron is protected and the more electropositive metal is get corroded. Whatever the external surface present, it act as a anode, so will be get a corroded burst leaving behind iron. So iron is get protected and then more electropositive metal will be get corroded. So this method is considered as a cathodic protection. Okay. Well, it's nothing but it also comes under sacrificial protection itself. Then coming to the third one, by using anti-rust solutions. Anti-rust is nothing but against rusting. The third method is by using anti-rust solutions. Well, basically, these anti-rust solutions are nothing but they are alkaline phosphate or alkaline chromate solutions. Alkaline phosphate or alkaline chromate solutions. They are used for preventing rusting. Okay. Well, here We know basically rusting takes place in acidic medium. In the sense, in presence of H plus ions, rusting of iron takes place. Now here, when the surface of iron is coated with either alkaline phosphate or alkaline chromate solutions. Okay, the surface of iron is coated with either alkaline phosphate or alkaline chromate solution. In that case, that these solutions prevent the availability of H plus ions. In the sense, whatever the alkalinity of the solution, basicity, that basic nature of the solution consumes the H plus ions totally. Means they absorb all H plus ions. Therefore, H plus ions are not available. So, corrosion can be prevented. Further, what happens? These phosphate and chromate ions, they react with part of the iron and get converted into iron phosphate and iron chromate respectively. Means in the solution, whatever the alkaline phosphate and alkaline chromate solution, whatever the phosphate ion and chromate ion is present, what happens? They combine with the iron and get converted into respective compounds, stable compounds, that is iron phosphate and iron chromate. Now whatever these compounds form, they are going to create a barrier, they are going to create a protective film on the iron surface. Therefore, rest of the iron won't be get corroded. So we say, by using anti-rust solutions also we can prevent the corrosion. So here, where these anti-rust solutions are used means, generally these solutions are used in vehicle radiators, or particularly car radiators, to prevent the rusting of iron parts. Okay, so it's like prevention of a corrosion. So by three methods we can prevent the corrosion. I can say particular rusting of iron. First one, barrier protection. Second one, sacrificial protection, and the third one by using anti-rust solutions. Well, I hope you got the concept. So with this, I am going to conclude the chapter, and in the next session we will discuss about some other concept of chemistry. Well.